All right, so we're going to find the determinant in number 32 is a 2 by 2, and 33 is a 3 by 3. So the way that this works is just a strict formula. It's a formula you either have to write down or have it memorized, and that's all there is to it. The formula derives from calling the elements like A, B, C, D. That's the usual custom. And then what we do is we kind of circle the diagonals because those are going to be the products. We're going to multiply A times D, but then we're going to subtract the product of BC from the product of AD. All right, and that's the determinant. The determinant is useful is that it determines whether or not you're going to have a solution in your system before you even begin to solve it. Okay, because if your determinant is 0, then you do not have an inverse. There's no inverse to find. All right, so it's always helpful to find the determinant first because the system might not even have a solution. So why are you gonna work, on this guy for so long? Okay. All right, so let's go ahead. Up to here, we get negative 15 minus 12, right? Negative 5 times 3 is negative 15 minus this product right here, which is positive 12. So you get a negative 27, and that's it. That's all there is to it. Now over here we have a 3 by 3. Now with a 3 by 3, what you've got going here is you have many determinants that you have to figure out. And that starts with the crosshairs here. So what we do is I kind of draw a row there. All right, and I put the determinant equals, and I'll just call it the determinant of A equals negative 4 times the determinant of this little guy here. And I'm just going to write that out. Okay, you will do one of these by hand. Okay, you have to do one by hand. This will be now a subtraction. Why? It's just because. All right, I know the next guy is a positive 1, but it needs to alternate, and the proof for that is incredibly complex and incredibly pointless for us to spend time doing it. But you're going to get 4, 2, 4, 2. Okay, then we will add these crosshairs here will give us a negative 4, and that determinant will be a 4, 3, 4, 3. Okay, so you've got 3 2 by 2 determinants to figure out inside one 3 by 3 determinant. Okay, it's just part of the formula. So what do we get here? We get 6 times 6 minus 6, that's 0. So negative 4 times 0. Minus 1, that's 8 minus 8, which is 0. And then plus negative 4 with 12 times 12 is 0. Okay, so it looks like we're going to get 0. All right, and that's just all there is to it. And that means then that if I were to, this has no solution. All right, so this will not have, when you have a determinant of 0, no. It doesn't have an inverse. So if it doesn't have an inverse, it will not have a solution. Okay. All right, so moving on, we're going to actually find the inverses. So to find these inverses, you use a formula here. We've got, let's see. We find that we will take the 1 over the determinant, and I notice on the exam a lot of you guys forgot to do this and just went for the switch. Okay, you just switched all the elements appropriately, but you forgot about the 1 over the determinant. So don't forget about these guys in the front. Now I imagine that this is going to be a negative 1 over 45 in just a second. We'll test that, but you have to switch these properly. So now I'm just going to write down the formula. What you do is you put the D here and the A. Now those two swap, but then the B gets its opposite sign, and then the C gets its opposite sign. Why? Because you are trying to undo multiplication. And by undoing matrix multiplication, going forward it's weird enough, so going backward it's even stranger. All right, so let's get that determinant. you're going to get negative 27 minus 18, which is negative 45. So negative 45. Okay, I'd never put the negative sign in the denominator. I'll always either put it on the top or right here in line with the fraction. And then I'm going to go ahead and switch all of my elements so that 9 goes here, the D goes here, the negative 9 here becomes a positive 9, and that negative 2 becomes a positive 2. Now, some professors will want you to multiply the 1 over 45 and put all of these over 45, but this is much better and makes much more sense when you're trying to solve for systems to leave this fraction out here. Okay? So it looks like this guy is letter B. All right. All right, let's do this guy here. We've got 1 over the determinant is going to be negative 40 minus a negative 20. So it looks like I've got negative 40. Yeah, negative 20. I don't know what I was saying. I was thinking minus negative. Okay, so negative 1 over 20. So it looks like this guys can go away. And I'm going to make sure that I do the necessary flips. That would be 8, negative 5. And this guy becomes positive. He will become negative. Okay, and then we use this to solve systems. But there's no system to solve right now. Okay, so this is as it is. It's just an inverse. So that's not it. Is this it? That's not it. Looks like this guy's here, so that's E. Okay, I know you have the answer key, but I'm going to make sure we circle the right ones anyway. Okay, now here's the real bread and butter here. This is what you would actually use it for. Now, one of the things that I did not put on the study guide, and that is important here, is that this does represent it represents an actual linear system. Okay, so I am going to give you a linear system. Now, we haven't discussed the calculator stuff yet. I'm going to do that separately in a separate video. In fact, it won't be the next one. Okay, it'll be the one after. But in this case here, what we've got is we have a linear system that looks like this. It's really negative x, 8x, plus 10y equals 16. Oh, wait, no. I don't know what I'm thinking here. Sorry. Oh, no, it's not the same. No, it's not the same. Yeah, it's not the same. Okay, so x, y. No, it is. No. Okay. Yeah. Okay. Need it. Okay, this linear system right here is that's what this is. Okay, and we can RREF it in order to solve it, but I want you to be able to solve as is using inverse matrices, not RREF. Okay, so this is inverse method. Okay, and then the RREF is yet another method that is much more elaborate or much better for bigger matrices, as you would counter in like more of a technical field. Now there's another method called Kramer's method, and it's just absolutely horrible. It's horrible. It takes a week to understand it, and sometimes they actually teach it in high school, and it takes a week to understand it, and it's just so bulky and so stupid. I hate to say that about particular methods in mathematics, but that one is, just Google it. Google Kramer's method and just look at a picture of it, and you're like, wow, okay, people do that, huh? Yeah, it's very old-fashioned. So anyways, let's use inverses. So what I'm going to do is I'm going to go ahead and find the 1 over the determinant, okay, because I need to find the inverse so I can multiply both sides by the inverse. If I multiply both sides by the inverse, this guy cancels out, okay? it's like the same thing as this. Like if I had 5x equals 7, I would divide by 5. But there is no division by matrices. So if I put a box around this guy like this, okay, what we're doing when we find an inverse is we're doing this. That's what we're doing. And then we're going to multiply it to this side right here. So we're going to squeeze it in just like that. That's really what you're doing with an inverse matrix, okay? Normally we can divide by 5 because division with just whole numbers is no problem, you know. But here, matrices, these guys will cancel out, okay? And then this would become the new matrix, the actual solution, because now you have x by itself, okay? So it would be like that. Okay, that's the idea behind. That's why you need an inverse. Okay, so let's get that inverse, and we're going to have negative 80 minus a negative 80 is 0. So if I do 1 over 0, I'm not even going to write it. The determinant is 0. So no unique solution. Now some of you might have forgotten about the determinant, started switching things, started multiplying, and you think you're doing it wrong because you don't see your answer, and it sucks. But do that determinant first because that's what it does. It determines whether or not you have a solution to begin with. Okay, so keep that in mind. Now over here, this is kind of would be more like a 5x minus 1 equals, I don't know, say negative 6. Okay, you got to take care of this guy first. Now you could you can do this in your calculator, but man, why? Just do it in your head, because if I am subtracting this matrix on this side, I need to add a positive version of this matrix to both sides, and then he's gone. Okay, so I'm going to rewrite this as negative 3, 2, negative 7, 4, C equals, and I'm going to do this in my head. This should be no problem. I'm going to add a negative 1 to negative 6. That's going to be negative 5. Add a 3 to this, and that's 1. Add negative 5 to here, and I get negative 13. Add negative 5 to 14, and I get 9. Okay, so now I'm back to what this problem is right here. Okay, so I find the inverse, negative 12 minus a negative 14, which minus a negative is positive, so it's 2, so that means I have a 1 over 2, and I'm going to switch these, make that guy negative, make that guy positive, and I'm going to multiply it to this guy right here. Okay? Now, what I've done is, by multiplying it to this side, that's that, and I'm just going to put an equal sign so that I'm squeezing this guy right in between here, okay? Because now C is all by himself. Okay, so I'm pretending that on this side I multiplied this guy by its inverse, because I just figured out what he was. All right, now, we are multiplying all three of these things, but this is a scalar. That's easy. That's just hyperdistribution. Okay, so we're just going to multiply these two first, and then we will actually multiply by a half or just divide by 2. So let's do that. So we got 1/2. Now let's go ahead and do this and this. We should get a 2 by 2 because we're multiplying 2 by 2 times a 2 by 2. So this guy here. All right, so now we've got negative 20 plus 26. This guy over here is 4 plus negative 18. This guy is 7, that's negative 35 plus positive 39. This guy right here will be 7 plus negative 27. Okay, let's figure out what those are. Remember, don't forget that half. We're going to divide every single one of these guys by 2 in just a second. So that's going to be 6. This will be 4. This will be negative 14. This will be negative 20. Okay, now I'm going to cut this guy in half. I'm going to get none of the right answers here. I screwed up somewhere. This is so annoying. 3, 2. You guys probably know where it was. It probably happened earlier in the video. I'm going to pause it. Pause it. Pause it. Pause it. Okay. That was stupid. So what I did was, I don't know where this guy came from. Where did he come from? It's this guy. That should be -6. Wait, no. Wait, no, time out. Wow, that was tough to find. It all stems up from this right here, that guy. -1 plus -6. I should have never changed his sign, right? Because we're adding -1. So that should have been a -7. Okay, so -7 goes here. Alright, so then that's -28. So that now we get a so we get 28. So that is a -2. And then this would become -49 plus, that'd be -10. Okay. Whoa. One little mistake. Okay. So this guy right there, making that one element, just adding mistake, right? And it trickled down into this situation, so that I had to correct these two errors here. So now, in this case, I'm going to take half of each one of these items. So -1. I should have paused this one while I was thinking about this earlier, but anyways. So it looks like cut those guys in half, and that's what you got, and that is A.